Well, good morning. Hope y'all are doing good. It is a beautiful day here in Middle Georgia. It's actually rained a little yesterday, so it's not quite as hot today. Later this afternoon, I'm sure it'll be humid as all get out, but right now it's comfortable. As you can probably hear, the birds are singing. They're quite noisy this morning, but it's a good day. Got something special in the shop today. It's I've never done anything like this, and I'm really looking forward to trying it. I've gone to YouTube University and looked at what other creators have done, and I've done similar type things, but never on anything quite like this. So I want to show you what I've got. It is this piece of machinery right here. This is a stump grinder that's owned by a friend of mine, and it's pretty cool. It's remote control and tire treads or tracks on it, and he can do all kinds of stuff with it, carry it places it doesn't tear the grass up. And it's phenomenal. And so he called me up and asked if I could do a repair on the grinding wheel, and a little leery of it, but I told him, yeah, bring it over, let me look at it, see what we can do. And after looking at it, doing a bunch of research, talking to other shops and things, the game plan is to take the cracks. We're going to clean them up really good, cut a deep V. We'll weld them with the MIG first, go on and fill the gap and start blending the crack in, so that doesn't happen again. And then once we do that, we will run a bead over it with a hard face rod that will give it a wearable surface that will deal with the constant abuse it's going to have through stump grinding. So let me show you what I'm looking at, and we'll move forward from there. This is what we're dealing with, y'all. As you can see right here, there's a crack. It starts right about there, runs all the way up right at the edge of this hard facing weld and around and down the other side about the same distance. The tooth here just bolts in. It goes through a hole. There's a nut down here on the bottom, so we're going to end up removing that. We'll come in. We'll probably start way down here, well beyond the crack, and we'll grind a heavy V all the way up and around to this side and get a good wide groove in there, so that we have no impurities and we have good metal to weld to. Then we'll come in, we'll fill it, and we'll run this hard facing over it to allow for the durability. So there's 3 or 4 places on here that are like that, and we need to get them fixed so he can get back in business. So let me get started on that. I'll bring you along. Yeah, we ended up finding 3 cracks. There was one right there, and I've got that looks like the crack continues, but it doesn't. I think that's, but we got that crack ground out. The worst ones, let's see if I can get it around to it, was this one. And I'm gonna have to go a little deeper on that one and widen it out a little, but I'm scared of losing the structure, so I'm probably gonna come in, clean the edges up, re-weld these edges so that when I go straight across to gouge that out, it won't lose any structural integrity. But here's what I want you to see, if it'll go in. Do you see the gap? See if I can get it to focus, I'm sorry. Look at how deep that gouge is. The original weld repair didn't go all the way to base metal. So there's actually a void in there, and I need to get that void out. The last one that we found is the same way. It's actually a little worse. So, same thing. You see the void in it. Oops, sorry about the crappy camera work, but you can see the voids down in there. A lot of porosity, a lot of garbage. And if you come over, let me see if I can get it focused, y'all. Sorry. I mean, you can see the hole right there. And I can actually take a pick and stick it down in that. And that's deep. So I've got to open those back up, widen them, and get all the way down to the bottom of that hole. But again, I'm a little worried about structural integrity. So I think we're going to clean this side and this side below the weld, or below that gap, and go in and weld this side and this side back up before we come in and try to clean that out a little more. Sorry about the finger in the screen blurring it out, but I just wanted y'all to see what I was dealing with on this. So I've talked to probably a dozen or so people, and every one of them tells me a different way to do this. Some of them say you have to use like a 70-18, 70-16 rod to do your fill, and then you come back with the hard facing rod. Another one says you have to do it acetylene. Another person said you can MIG weld into to join everything back and then hard face over the top of it. I'm going to MIG this to fill the gap and to fill the voids, because I have more control with that than I do with the stick welding. And then once I get the stick welding, or get everything filled with the MIG, then I'll come back and I'll run the hard face with a stick weld, because then it's the flat surface over the top. So that's why I'm doing it the way I'm doing it. Right, wrong, or indifferent. Like I said, I've talked to several people. They've had great success with this, and that's the way I'm going to try to do it. So we'll see if it works. Okay, y'all, I started welding this up, and my nozzle ended up getting blocked and causing some spatter. You can see the porosity in the weld, so I've got to grind this back out and try to do it again. Okay, so we got the porosity out, we cleaned it up, we hit it again. It's not the greatest welds in the world, just because of the angle we're welding at, but we've got it filled. So now we'll come back with the hard facing rods, and we'll run from here down to this area, and we'll cover all of this with hard facing rods, and we'll probably make another pass over this up here. We've got to clean all this. It's got to be super, super clean to do the hard facing. Okay, so before we weld, there's a couple things we need to do. We need to make sure everything is absolutely clean, and so we'll wire brush it really, really good. I've got a wire brush on a grinder, so I can hit everywhere and make sure it's really, really clean, almost to a polished finish, so that we don't run into any impurities and we have a less chance of porosity showing up in it. The other thing we need to do is we've got to preheat where we're going to weld. And so you can't, let's say we're going to weld right here, you can't just heat that area. You actually have to heat all the way back through, let's see, to right here. So all of this area around it needs to be heated, and it needs to be heated to around 200 degrees. So that's what we're going to do with the Benzomatic, the little map gas torch there. We'll heat it up, and then we'll be ready to weld. So this one was welded with not preheating, so you can see how globbed it is, and how I cleaned a ton of it off and went back and preheated and tried to re-weld it, and it just looks like garbage. This one did really well. We preheated it, we cleaned it real well. You can see a couple areas like right here and right here on the other side where I tried to make a second pass without stopping and cleaning, and you can see the results. So, but where I cleaned it good, we had a really good bead, and the pass looks good. And then here's the other one. It was just kind of this area. And again, prep. Okay, y'all. That is a lot harder than I thought it was going to be. The welds are not pretty, but they're not going to be. They're for wear and tear and abrasive resistance, so it's not going to be a pretty weld, but I don't know. They seem to be holding on real well. They seem to have worked out. They got good penetration, so I think we're okay with them. We're going to do a little cleaning up and get the teeth back in. Well, that was fun. Very interesting lesson. So, a couple of things I learned. Number one, that the base metal has to be clean. I mean, like spotless clean. Also, you have to preheat it. If you don't, the welds look like garbage. They don't stick well, and it just creates a ton of problems. So, yeah, you got to preheat it up to about 200 degrees. Also, with these, I had to adjust the settings several times. I started off at about 75 amps. Kicked it up to 85, kicked it up to 100, back down to about 90, I think is where I finally finished up. Your amperage makes a huge difference. Too low, and it won't stick. Too high, and it burns in really, really deep, and looks like garbage. They're not going to be pretty welds to begin with. It's not. You're putting this on in globs, basically, and it's to protect the base metal from being eaten up by corrosion or abrasion or something like that. So, you know, for the first time I did it, I'm not disappointed with it. I want to get better at it, and, you know, I'm glad I got the opportunity to try this. So, any tips y'all have would be great. I'd appreciate it. Like I said, it's new to me, so I'm still trying to figure it out. But the only way you figure it out is by trying to do it. So that's what I did. Hope y'all are having a good one. Take care. See you soon. Oh yeah, shop safety tip of the day. Make sure you wear the proper boots. You don't want to burn through your shoes.